Hi everyone, this is Mrs. Mast. This is going to be the PowerPoint on variables and expressions for translating expressions. The objective is to be able to write mathematical expressions for verbal expressions and vice versa. The focus question is, how is an algebraic expression different from a numerical expression? Vocabulary we worked on in a previous lesson, so we're not going to touch on that during this lesson. For the warm-up, consider the population of Florida and the area of Colorado and the flight time from Philadelphia to San Francisco. Which of these has a value that varies? So here's San Francisco and here's Philadelphia, so you can see the flight from there. Here's Colorado, and here's little people representing the population of Florida. So which of these would vary or could change? That's another word that can be used for varies. Which of these can change depending on the situation? So the answer would be Florida, because population changes on a daily basis. People die, people are born, so the population in Florida is never the same day to day, or month to month, or year to year for that matter. The flight time from Philadelphia to San Francisco is always going to be the same. The distance is always the same. And the area of Colorado is always going to be the same as well. Land doesn't grow or minimize, so the area of Colorado will always be the same. To translate word phrases into algebraic expressions, look for words that describe mathematical operations. So words that describe mathematical operations are listed over here in this column, and it's broken down into addition, subtraction, multiplication, and division. Words that describe addition are sum, plus, more than, total, and increased by. Subtraction, the most common, are difference, minus, less than, and increased by. And for multiplication, product, times, multiplied by, and of. And for division, quotient, and divided by. And these are the more common names that you'll see used for each operation. There are definitely more, but these are the most common ones that we'll see. And using these in algebraic expression. So an algebraic expression, remember, is an expression that uses a variable or a letter. So 5 plus x, or x plus 5, can be read in the word phrase, the sum of 5 and a number x. Or 5 more than a number x. Or 5 increased by a number x. So all of these word phrases represent this single algebraic expression. Same with the subtraction. So n minus 7 can be read as the difference of a number n and 7, or 7 less than n, or a number n minus 7. Multiplication, remember that this dot between two numbers or two letters or a number and a letter, in this case, represents multiplication. Same with if a number and a letter are right next to each other, that represents multiplication as well. So this can be read as the product of 4 and y, or 4 times a number y. And for division, n over 2, that represents division. So when you see a fraction, that also means divide. So that means the quotient of n and 2, or n divided by 2. Translating verbal expressions into algebraic expressions. So this example is 4 more than a number y. So the verbal expression is 3 more than a number y. I should say 4 more than a number y. Algebraic expression, it would be 4 plus y. So write each expression algebraically. The product of 7 and a number x. So the answer is 7x, because product means multiply. The difference between 15 and y squared. So the answer would be 15 minus y squared. And you have to put, the difference means subtraction, and 15 and y. The 15 has to go first because it's red first. So the difference between 15 and y. So the 15, you're subtracting y from 15. And remember that squared is an exponent, which is also 2. So it goes, you have the little script over here, up here, with 2. The sum of 4 and m. So sum means add, so you have 4 plus m. T divided by 3. So divided by obviously means divide, so t divided by 3. Again, the t has to go before the 3 because you're dividing t by 3, not 3 by t. 4 times 7 plus n. So the answer is 4, parenthesis, 7 plus n, parenthesis. And this one has an extra step in it. So it wants 4 times whatever 7 plus n is. So you have to add 7 and n first and then multiply that times 4. So that's where the parentheses come in. So you know when we get to orders of operation, we'll see, you'll learn that you do whatever's in parentheses first. Now we're going to translate algebraic expressions into verbal expressions. So this example is 5m. So an algebraic expression is 5 and the dot m. And verbal expression is 5 times a number m, or the product of 5 and m. So write a verbal expression for each algebraic expression. So 4 minus t. The difference between 4 and t. Because difference means subtract 4 and t. X plus 8. The sum of x and 8. Sum means add, so that's why you would use sum. 3 divided by s. The ratio between 3 and s. So ratio means divide between 3 and s. 2z. The product of 2 and z. Because these are right next to each other, that means multiply. And product means multiply as well. So the product of 2 and z. 21d minus 4, or 21 times d minus 4. See? The difference between 21 times d and 4. So again, in orders of operation, you do multiplication first before you do subtraction. So you would multiply 21 and d together and then subtract 4 from that. So, and again, difference means subtract, so that's why you would write it as the difference between 21 times d and 4. And we will learn about power in the next lesson.